How do we determine the factored form for higher ordered polynomials? Well, let's start with just a number, not polynomials. Let's factor 220. All right, I can take a 5 out of that, and I'm left with 44. 44 breaks down, I can take a 4 out, and I'm left with 11, and I can break down my 4 into 2 times 2. So 220 factors into 5 times 2 times 2 times 11. Okay, how did we figure that out? You most likely used your calculator, but we could have used long division. Remember that from elementary school? So let me refresh your memory on long division. You say to yourself, 5 times what is 2? Well, that doesn't work. 5 times what is 22? Okay, well, 5 times 4 is 20. That's the closest we can get. Let's subtract. So I said 5 times 4 gives me 20. Then I subtracted. And I can bring my 0 down. All right, repeat the process. 5 times what is 20? Oh, it's another 4. 5 times 4 is 20, and I'll subtract and get a remainder of 0. And because the remainder was 0, we knew we actually had a factor and everything worked out. Side note, if you had tried to factor out a 3 or something like that, let's try that actually. Let's try and divide out a 3. 3 times what is 2? Well, that's not going to work. 3 times what is 22? Well, 3 times 7 is 21. Subtract and bring your unused term down. 3 times what is 10? 3 times 3 is 9, and that's the closest we can get. Subtract, and I have a 1. Then I have to start adding in decimals if I want to keep dividing this out. And I'm going to have to keep adding decimals because it's going to just keep going and going and going. Because my remainder here was a 1 and not a 0, 3 didn't divide out evenly. I ended up with decimals. So 3 was not a factor. Notice that didn't end up in my factor tree anywhere. All right, we're going to apply that same exact logic to polynomials, things that look like this. Before we do that, maybe I should tell you some of the vocabulary. You don't need to use this vocabulary, but I am going to use it while writing the steps, and so it may help us. Okay, the divisor is this 5 or whatever you have on the outside that you're dividing by. The dividend lives under the house. That is the number that you're dividing out of. The quotient is your answer, and the remainder is whatever you have left over when you're when you're done dividing. Okay, so what steps are we going to do? Here we said 5 times what gives me 22. You're going to do the same thing. The first term of my divisor times what will give me the first term of my dividend. I put my 4 on top and said 4 times 5 is 20, and then I subtracted. So whatever answer we get, we'll put on top and distribute it times both or all 3 pieces, times all pieces of my divisor. Put it down here and subtract. And then finally, once I subtracted, I brought down this unused 0 so I could actually use it in the next step. So same thing down here, you'll bring down any unused number so that you can use it in the next step. All right, let's actually do that now so you can see this in action. We're going to use long division. That's what this is called, long division. We're going to use long division to divide x minus 5 from this polynomial here. So set it up. All right, x times what will give me x cubed? Well, that'll be an x squared. Distribute your x squared to all pieces of your divisor. So x squared times x is x cubed, and x squared times negative 5 is negative 5x squared. And now we're going to subtract. That means change your signs and add straight down. So x cubed minus x cubed, that goes away, which was the whole point. And negative 9x squared plus 5x squared is negative 4x squared. Last step, bring down these unused terms, and we're going to repeat the process. All right, Now, x times what would give me negative 4x squared? Negative 4x. All right, distribute. So negative 4x times x is negative 4x squared, and negative 4x times negative 5 is positive 20x. Subtract. That means change these signs and add. Negative 4x squared plus 4x squared is 0, which was the whole point of that. We wanted that to cancel out. And then positive 15x minus 20x is negative 5x. Bring down the unused term and repeat. So x times what is negative 5x? Negative 5. All right, distribute. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. Subtract. So change your signs and add. That's what subtracting is. Negative 5x plus 5x, that adds up to 0. And 25 minus 25 also adds up to 0. So we can write this in factored form. I factored out an x minus 5, and there's a 0 remainder here. So x minus 5 times this with 0 remainder gives me my original polynomial. I could actually break this down even further because we know how to factor this. That would be an x minus 5 and an x plus 1. So that is how they get the fully factored form of a long polynomial like this. You divide something out. If you end up with a 0 remainder, then you can break this piece down even further, either by doing division again, by doing quadratic formula, or in this case, it was quick for us to factor it ourselves. And note that x minus 5 is a factor. It's part of the factorization because the remainder was 0. Just want to hit that hard. Remainder is 0. Let's do 2 more examples. Long division is very repetitive. Make sure you pay attention to your signs and get everything right. All right, let's divide this by 3x plus 1. Okay, 3x times what gives me 9x squared? 3 times 3 gives me 9, and x times x squared gives me x cubed. So that would be a 3x squared. Generally, it's going to be 1 degree less than what's under here, as long as this is to the first power. If it was squared, then it would probably be 2 degrees less. All right, distribute that. So 3x squared times 3x is 9x cubed. 3x squared times 1 is 3x squared. Subtract. That means change the signs and add. That adds to 0. This adds to positive 15x squared. And bring down your unused terms so we can repeat the process. All right, now you say 3x times what is 15x squared? 3 times 5 is 15, and x times x is x squared. If you end up with 3x times what gives you, say that was a 14, and so it didn't end up nice and pretty, you probably messed up. In real life, you can end up with weird fractions and decimals, but in math class, we're going to make sure these are all whole numbers, so just be aware of that. All right, so 3 times 5 is 15, x times x is x squared, so this is 5x. Distribute your 5x, so 5x times 3x is 15x squared, 5x times 1 is 5x, and now subtract, so that's changing our signs, and then bring down any unused terms and repeat. 3x times what is 3x? 1. Make sure you actually write your 1, not a 0. We don't just ignore that it exists. 3x times 1 is 3x. All right, multiply. 1 times 3x is 3x, and 1 times 1 is positive 1. Oh man, I typoed this problem. But you know what? That's okay. So subtract, subtract. This ends up being a 0, so my remainder is 0. So that means, again, I can write this in factored form. it would be 3x plus 1 times 3x squared plus 5x plus 1. And if I wanted to break this down even further, I would have to do quadratic formula because that doesn't factor out nice and pretty. So I'm going to do quadratic formula real quick just for you to have a quick example of that, but I'm not explaining. You should know how to do quadratic formula for this. Oh, okay, that doesn't break down any further. So that means that we have the factors x equals -5 plus your square root and x equals -5 minus your square root all over 6. So if I did want to write this in factored form, these are my x-intercepts, but my factors, I need to subtract this over to the other side. So x minus that fraction. This is my factor. I know it's really messy. I didn't actually mean for this to happen in this example, but I'll show you this in the next step to make it a little bit easier for you. Ooh, you could distribute that negative if you don't like all these parentheses. Distribute the negative and distribute the negative. That's probably what I would do. Your homework leaves it like this though, so if we were going to fully factor this, our answer would be that. And now I've gotten us way off track and made this more difficult faster than I meant for it to be. But you will have to practice this on homework, so I may edit that out. Okay, and again, this was a factor because we ended up with a remainder of 0. Okay, let's do one last example where we don't have a factor, so we can't break it down any further, and we don't have to worry about that. All right, x times what is x cubed? Distribute. Subtract. And bring down your unused terms. All right, x times what is 6x squared? 6x. Distribute. Subtract. Bring down your unused terms. X times what is 7x? Distribute. Subtract. Okay, so when I divided out, I ended up with this quotient. Because my remainder is not 0, this is not a factor, which means that x equals -2. If I set that equal to 0 and solve for x equals -2 is not an x-intercept. So the difference between factors and x-intercepts is factors have plus or minus a number. X-intercepts are x equals. Okay, so there's a quick way for us to check our work here. There's something called the remainder theorem, and that is any factor that you have, if you sub in the x-intercept into the original equation, it should equal the remainder. So for some factor, x minus c is our factor. If we set that equal to 0, then x equals c is our x-intercept. All right, so if I sub c into the original equation, whatever y value I get is going to be the remainder. Why is that helpful? I just said that earlier. We can sub this -2 into our original equation and check to make sure we got the same remainder. So let's do that. Let's sub in a -2. We get a -28. So that means that is our remainder and everything's good. We can double check this here too. If 3, it doesn't exactly work if you have a number in front of your x. So let's actually not do it there. But we can do it with this problem. X minus 5 is our factor. X, if we set that equal to 0, x equals 5 is my x-intercept. So if I sub 5 into this original equation, I should end up with the remainder, which was 0. Perfect. So in this class, we could use this as a quick way to figure out our starting term. If I don't give you this and I say I want you to completely factor it, give me the complete factorization, you can just plug in a bunch of numbers into this equation, and once you get a 0, you know, hey, I got my first factor, let's divide it out. I'm going to always give you a factor, a starting point, but just know that that's one thing you could do. And then also I want to mention that Alex may teach you a different way called synthetic division, and synthetic division will work only if you have x plus or minus a number. If we are trying to divide by something like this, where we have a 3 in front of our x, or if we had an x squared here, synthetic division will not work. So that is why we're doing long division. Synthetic division is a great shortcut, but you need to know how to do long division for later math classes and for this class.